All right, see a few people rolling in. This is Tyler's session, Agentless multi-cloud deployments using Idem. I am chatting with him, so he should be joining soon. And then we'll still wait until a minute after just to let people join. All right, thanks for joining. Oh, here is Tyler. Let's let him share his audio and video.
Okay. Can you hear me okay? See me okay?
I can. It's working.
Perfect.
All right, we'll give folks just maybe till 1 minute after to keep rolling in.
I'm going to practice sharing my screen real quick.
Yeah, please.
Nice.
Oh, there we go. That is nice, legible type. I appreciate that.
All right, here's what I want people to see as they come in. Good rules to live by.
Namespaces are one honking great idea.
Yes, Idem and Pop definitely use
Check that.
Yeah. More than anything else I've seen. Okay. It's working. I got it working with Chrome. It was just I needed my settings to.
No problem. For everyone joining, we'll start in a couple minutes. Just giving folks time to roll in. This is the agentless multi-cloud deployments using Idem.
I'm trying to make the title sound really interesting.
What's that?
I was trying to make the title sound really interesting. I think I'm a little pretentious. I mean, that's what it is. It's just.
All right, we'll pretend like we're starting the recording right now or something. I think we're about good. So thanks everyone for joining this session. This is agentless multi-cloud deployments using Idem with Tyler Johnson, and a little bit about Tyler. Tyler started as a Linux system administrator and learned Python doing QA testing on home automation devices and controllers. And at Salt, he quickly became the cloud guy, and eventually that shifted into developing Idem full-time, which he's been doing for the last 2 years. So with that, I'll hand it over to you, Tyler.
Thank you, Dave. Yeah, I've been doing Idem for quite a while. up there with Nick Hughes in time that I've done it, and I mean, no one's done it as long as Tom, because since he's the creator. But so you've probably heard a lot about Idem already. If you've been to VMworld, if you've been to Keynote, or you've been hearing about it in the community. Idem is a language runtime, and some of the parts of what I want to talk about today, I want to look at some of the major components of Idem inside the code, and then I want to show at a high level how to use it, and then how we can use it inside of Salt. So that's a high level what we're going to go through here. When I started working on Idem, it was about 2 years ago, and I was first working with Tom on Tiamat when that was brand new in its infancy, and then Nick Hughes showed off what he had done with Idem, because Tom had talked to him and got him or helped him get started, and he wrote the Idem Azure RM. And then it was there was this kind of gray area where we didn't know what Idem was going to become. It was like, oh, this is like Salt States, but improved. And then it was like, oh no, is it going to replace Salt? And then every time anyone asks me that question, I'm like, no, nothing is going to replace Salt. Salt is forever. And but Idem can do anything that Salt States can. Like you could write an Idem plugin to manage a file or to manage a service. You could make it do that. One of the differences, though, between Idem and Salt is that Idem is agentless. We don't require any master and minion to run it. And so as we were toying around with Idem, there was a time when I would try to rip out salt grains from Salt and implement salt grains in Idem. And that was a great learning experience. And it didn't really, it wasn't the final resting place of Idem. That's not where it was going. And I was like, oh, we'll just do the package management, or we'll do, we'll use Idem to wrap Salt. And all of those were dead ends. And then finally what we hit was cloud. And then that's when Idem's story started to become even more clear. It was like, with cloud, we don't need an agent. It doesn't make sense to send a task off to a minion to do work when you don't really need a minion. So we considered making it a Salt runner, or so many different things. And cloud really became what we found really worked well with Idem. And so then we started developing we started adding these features to it, like how do we do providers and profiles and get the context to the right states in a very elegant way that allows us to do multi-cloud automation. And that's some of what I want to show today too. So Idem, if you followed me specifically over the past 2 years, I've said Idem is this, and it's been a kind of a story that has been evolving into what Idem is today, which is Idem is currently being used for multi-cloud. So I realized I'm not sharing my screen, so I'm just going to share my notes with the slides. You get to see everything that I'm seeing. So this is my information. This is me and M, Nyan Cat. I'm a huge fan of the Nyan Cat. I have 2 cats myself. You can see all of the projects that I'm publicly working on gitlab.com/Ahmad. That's my handle. And I'm also on LinkedIn as Ahmad. That name kind of started off, just a quick side note about my name. Exclusive, hold on. I'll get to questions at the end, but I will take some of these questions as an answer. So quick aside about my name, or my handle. Ahmad, I had studied in Jerusalem for a while and had a chef that could cook anything, and his name was Ahmed. And so then I came home and I was like, oh, I'm going to make a variation of that for my gamer name. And so then it was Ahmad. And then one day someone asked, oh, is that a hacker name? And then it stuck. So it's like I am the asynchronous kernel module. I do things to the kernel that it doesn't expect. So that's where it came from. If you see my name and you're like, why that? So okay, now we're gonna dive into things. So this question, exclusively cloud, no longer states. Idem runs states, but in the cloud. And I think that question you'll get answered more clearly as we go on. So first, I want you to look at the idem command. There are 5 subcommands in idem. First is exec, which from the CLI you can run exec modules. The idem state command, which is used to run SLS files, and describe, which I'm really excited about describe, and I'll show that in a sec, which creates valid present states. So another of the differences with working with the cloud versus Salt scope, which Salt scope is huge. What Salt can manage, there are so many different ways you could manage a file or a service or everything. But when it comes to managing the cloud, there's a finite number of things in the cloud. So what the describe subcommand does is it gives you a base point for writing your states. If you've never used Idem before and you want to start using Idem to managing your AWS instances or your GitLab project, all you have to do is say Idem describe AWS, and it will create valid present states for everything you currently have in the cloud. And then from there, the idea is you can now use it to manage your states. You could run idem describe before a state runs. That way you have a point to roll back to if you ever need to. So the describe command is something that's really cool, and it has its own story. It has a story of its own. The encrypt subcommand and decrypt subcommands, those came from the ACCT command, and we rolled them into Idem because as we're looking at TMAT and building all these Idem functionalities into a single binary, it became apparent that we couldn't have everything disparate into separate commands. We needed everything to be part of the Idem binary. So let's look at some of these in action. I'm gonna make a new virtual environment with my thing right here. And Idem. Demo. I use that. Demo 2. Oh shoot. Whew. Okay, pip install Idem. Just start with that. All you got to do to get started with Idem. So let's look at running an exec module. So that was the exec subcommand. Well, first let's look at the Idem command. Root. Here's the 5 commands you described: decrypt, describe, encrypt, exec, state in nice alphabetical order. Some logging options that show up in every project, and some other options related to the operation of Idem. Then Idem exec. Here are these account file, account key, account profile options. This is how you can specify specific credential stores or a specific profile within those credential stores on the CLI when you're running an exec module. So that way, we'll do a workshop later where I'll go even more in depth with Idem AWS and show how you can use credentials on the CLI to create a VPC or create an instance. But I keep wanting to, I want to emphasize that exec modules are great and you can use them from the CLI. You can run them directly, but states are where you want most of the work to happen. If you're writing an app that is using exec modules heavily, you're going to end up rewriting most of what the states do, what the state system does from scratch. So just use states. So using this, I'm going to do idem exec test.ping. True. There we go, our very first exec module run from the command line. And you can also specify different outputters. And we'll get more into why when I output JSON, why it looks more like this. That's that. So the describe command. If I run idem describe test, I get a valid present state with all of the test states inside of item. I could pipe this to an SLS file. And yeah, there we go. And then now I can run item state test.sls. And that's it. I've gotten started with item. Using 2 commands, I wrote a bunch of states and ran them. And some of them, since these are test states, some of them are not having changes, some of them are failing with changes, without changes, and so on. But yeah, but I could edit this test file right now. And if I've never written item states before, this is my starting point for playing around with item or playing around with states. You could play around with the requisite system just by running item describe test. You have a base point to start playing with item. So I highly recommend just doing that much. Pip install item describe test, and then yeah, start looking deeper into all of that. So we'll go deeper into the encrypt and decrypt subcommands in a little bit, and that is tied to how item stores credentials. But first, we're going to talk a little bit more about these internals. So each of these subcommands is kind of what is the target of those examples? There is no target. So like I said, item has found its niche in the cloud, or its niche, however you pronounce that, in the cloud. But those examples, they're just running on my local machine. I wasn't using any credentials. If we look at the actual exec module over here in test, the ping, it just immediately returns true. That's it. And some of these bigger questions I'm going to talk to more at the end of the presentation. So each of these subcommands is tied to specific dynamic namespaces inside of item. And so dynamic namespaces, if you're familiar with POP, or if you've heard about POP, these are subsystems that can be extended in other projects. So there's the exec dynamic namespace, and that's where we put exec modules that do the work, states, where most of the logic happens, and tool for miscellaneous helpers, ACCT, which is our authentication plugins for item, and account backends. And this can be used for alternate profile backends. Like you can use LastPass, or you could write a plugin to store your credentials in any secret store that you want. For some reason, LastPass was the one that I experimented with first. And then outputter plugins. And those are those come from the Rend project. So any project, so the great thing about item is that it's scalable in its development. So if you want to get a feature into item, if you want to get a new cloud functionality into item, you don't have to wait for the next release of item. Item is just the idempotent runtime language. It does requisites, it handles states, it does all of the very, very core functionality. And any cloud functionality is in its own project. It's tested on its own. And so if you come over to gitlab.com/vmware item, this is where all of the item projects are that we're currently working on. Item Azure, VMC for VMware, AWS, IA, IOHTTP, GitHub, GitLab. And all of these projects they extend the dynamic namespaces of item. So for example, if we look at item GitLab, it extends the dynamic namespace of account, exec, and states. And so we have within item GitLab, have you never seen it before? This is what a state looks like inside of item. any project that wants to extend functionality in Idem just needs to extend the dynamic namespaces of Idem. And you can implement some of them or all of them or extra ones. So that's that. So exec modules have kind of had a little bit of a journey too within Idem. At first, we were writing exec modules for the first iteration of Idem AWS. And Idem AWS, it's been rewritten 4 or 5 times now. And it's on its final iteration. It's where we got is a really good place. But at first, we were trying to write exec modules from scratch and then having to write states from scratch. And it was so tedious because trying to get all of the functionality from Bodo and writing an exec module for everything inside of Bodo, there was no way we were going to be able to keep up with it. It would have taken a team of 20 people, like full-time jobs, just to keep up with Bodo in Idem. And so I was doing some Twitch streams about Idem, and then Derek Ardolf, he was experimenting with auto-generating code because he started noticing there's a whole bunch of patterns that I'm following as I'm doing these exec modules. And Idem and Pop are all about exposing patterns and finding patterns. So eventually we got to where we were auto-generating exec modules, which is we had written some automation to write the exec modules for us by parsing the Bodo API. And that was great, but then quickly it was like, okay, well, now we've got to handwrite the states because we're auto-generating the exec modules. So then we took a different direction, and exec modules became a raw wrapper of the API. The only purpose of an exec module was to be a direct translation to an API. And you can see that evident in the current Idem AWS. In its exec modules, it has one exec module. And all this exec module does is it translates a path like bodo3.client.ec2.create_vpc. It translates this into creating a bodo3 ec2 client object, passing it the right credentials, and then calling create VPC on that with the rest of the arguments of the command. So that's a lot to look at. You can read the documentation for Idem AWS or for this exec module directly. But what I want to show here is that exec modules became a direct translation to an API layer. And so then from that point, we didn't need to write exec modules anymore because they just directly call an API with the right credentials using Idem's credential system. And that's the other thing that exec modules do is they are aware of a context that has the right credentials for the right state or for the right job. Another thing, shout out to Christian McHughes for pushing for this change. Is exec modules in Idem must return a dict that has their status, which is if they were successfully ran or unsuccessfully, a return value, which could be anything, any object or value, and then a comment string. So we now have a predictable return from exec modules, and we know whether or not they were successful when they ran. So that's something else that's different from exec modules in Idem or in Salt. So then this last bullet point, if you've been looking at this, might seem a little bit curious. This is a brand new feature. Like it's still like in its last 5 minutes in the oven. With Pop, we can make use of contracts, and contracts in Pop enforce that certain functions exist, that they have certain return values, and you can choose to implement contracts. So what's coming in I think we're on release 14 of Idem. What's coming in the next release of Idem? I'm jumping all over the place for a sec. This is coming in the next release of Idem. Because we've noticed over and over that the exec modules that we're writing for Idem Cloud projects follow very specific patterns. We were able to write code that wrote the code for us for writing states. And I found that for writing a state, there are 5 functions that I need to know about any resource. I need to know how to get it, list it, create it, delete it, and update it. And if I have those functions, those 5 functions returning in a predictable way, I could easily automate the creation of a state. And so what that became is if in an Idem exec module, you have these functions and you implement the auto state contracts, Idem will dynamically transform that exec module into a state. So that's a lot of magic that happens in there. But the contract enforces that your get function has specific parameters, that it returns a dictionary, formatted like this, that your list function returns a dictionary, not a list, that your create function has specific parameters and so on. And then it's able to, because the states, they follow very specific patterns for the present, absent, and describe functions that are inside of a state. And so this is the most simple way to write a state in Idem, is to implement the auto state contract and tell me how to do those 5 things with a resource, and Idem does the rest for you. So that's another way to do things. So state modules, which I recently called out to right there. There are 3 functions that I expect inside of a state module. And again, you could write a state module with any name. You could have a function of any name. But if you implement the resource contract, then you're required to have a present, absent, and describe function. So the present function checks if a resource exists, creates it if it doesn't exist, and make sure that attributes of the resource match the parameters passed to the states function, and then it returns a diff of the changes. Absent functions are even easier. They check if a resource exists. If it does, it removes it. That simple. And then the describe function creates valid present states for a resource using the given credentials profile. So we can actually see this pattern expressed very well in the auto state state. So this is the state that takes, if your exec module plugin follows the auto state contract, then this is the state that ends up being created. It gets the before status. If that is false or if that is not successful, then it calls the create function. And then no matter what, it calls the update function, and then it gets the after status and returns a diff. Like that's all we need for a present state. And people that were writing states in Idem, the hardest part was getting past the tedium of writing this over and over and over and over again. And so that's where the auto state contract was born, where it's just like writing a present state is the same thing every time. Just tell me how to get, list, delete, create, and update a resource. And this is what the state needs to look like every single time, pretty much. Yeah. Oh, this is on an older commit. So in the describe command, as you can see, I'm getting the parameters of my create function, or whatever the create contract is in your exec modules, and I'm matching the listing of the resource to the parameters of the whatever your create function is, and creating a valid present state based on a matching of those. And so what happens is just by implementing those 5 exec module functions and the auto state contract, you get the describe functionality, you get an absent and a present state, you get the full power of Idem just by telling me that about any resource. So how do states look like? So now let's talk about the credentials file. So this is what the item credentials file looks like. It can be YAML. Technically, you could use any input renderer because the rend project can read JSON or it can read, I don't know, .ini or whatever format you want to follow. But I figure most of us like YAML, meaning Salt developers. And don't worry, these credentials are safe. I've ripped out anything that is remotely private. So what you'll notice is over here, I had on the first layer of the YAML file, I have the provider, which is AWS or Vultr, Azure RM, or AWS.G Suite. And I guess that's a little bit more complicated. And then at the second layer, we have the name of the profile. And at the third layer is all of the parameters that go into that specific profile. And so for AWS, I have two profiles, default and test development AWS. And for Vultr, I have two profiles, default and my bare metal profile. And yeah, you can see that pattern followed everywhere else. I actually have more than two profiles for AWS because I have aws.bodo, aws.g suite, and aws.gsts. So with account, we can have different authentication plugins. The default that uses endpoint URL and access key ID and secret access key, this is passed, these arguments are pretty much passed straight into Bodo or into the creation of a client object within Bodo 3. And so, but there's a G Suite plugin or a GSTS plugin in the Idem AWS project that will take your Google username and password and will authenticate to Google and then generate an access key ID and access key and then pass that on. So one of the advantages we get with Idem and with the account subsystem is we can authenticate however we want because there are so many ways to authenticate to Idem or to AWS. And we can make use of all of them and then have a universal API under the hood to use it. So this is what your credentials file looks like. And then once you've created your credentials file, let me just create a raw credentials file. If I say AWS, my profile is called default and access key foo. Okay, just an empty YAML file or a YAML file with some basic valid YAML in there. So once I've populated my credentials file, I say idem encrypt creds.yaml. Hold on. Idem encrypt creds.yaml. And it'll spit out the fernet key because we use the fernet algorithm to encrypt this file. It'll output the fernet key that was used to encrypt this file. And so then the first thing I want to do with this fernet key is I want to save it to an environment variable called account key. And then the encryption command also created a file. I'm using the Windows terminal for presentation. Let me see. Account key equals, I'm going to actually do this. So it also spat out this file called creds.yaml.fernet. So I want to say, I want to make sure that the account file environment variable is the absolute path to my encrypted YAML file. And so now I can say idem decrypt. Now I can remove my credentials.yaml, and I don't need to keep any plain text credentials anywhere on my system. If you're using idemd, which is outside of the scope of this, you don't even need to keep the encryption key and the credentials file on the same system. It's nice. So now if I ever want to edit my credentials, I just need to say idem decrypt creds.yaml.fernet to, shoot. Live demos. We'll work that later. Test it before you delete your plain text credentials. Yeah, the idea is you don't have to keep any plain text credentials around on your system when you're authenticating to Idem. So that's what the credentials file looks like. So now how do we use this? We noticed earlier when we're running the idem command, like when I run idem exec help, I can specify, if I didn't want to set those environment variables, I can specify the encrypted credentials file on the command line, or I could specify the account key on the command line. Or I can specify the profile. So a quick word about that. How are we doing on time? We're doing really good on time. I don't want to go into details about this right now, but this is in the Idem AWS project in the states file. This is how Idem is aware of which provider matches to which states. So in the Idem AWS states, I have this hub states AWS account AWS. That means all states under AWS will use the AWS provider to authenticate. And you can specify multiple providers if that makes sense for your project. And I've very rarely had to do that. And we can go into detail. You can talk to me after if you want to know in detail how this works and why this works. I just if you're writing your own authentication plugin or you're writing your own cloud plugin, I just want you to be aware there is some magic sauce that makes Idem aware of which provider profiles match to which states. So running with that now, this is an example of a multi-cloud state. I have a state that ensures that a firewall group exists within Vultr, and then I've named a specific account profile to use. So from over here in my account profiles, I have Vultr bare metal profile, and that's the profile that's used to ensure that my firewall group exists. And then I have a different profile, my default Vultr profile, that makes sure the firewall rule exists. And then over here for my AWS IAM user.present, I'm using my default profile. And then for making sure a role exists, I'm using my test profile. And those exist over here. I have a default profile for AWS and then a test profile. And then I also have in this Azure RM resource group.present, I am requiring that my Vultr firewall rule exists first. So this state must run successfully before my Azure state will run. So what you get is you can write a state that manages multi-cloud operations or resources and even multiple credentials within the same cloud in the same state file. And you can have them require each other. You can have them, there are more advanced requisites that you can read about too. This is where the exciting part of Idem is the multi-cloud operation and multi-credentials. So yeah, just take a second to chew on that. So my last slide here really is how Idem can be run from within Salt. Since version 3002 of Salt, you can run Idem exec modules and states from within Salt. All you need is the state name, and you say idem.state is the specific state that's running, and specify which SLS files you want to run, or specify in the parameters for the state which account file, account key, or account profile you want to be the default in here. That's really all I had for this, was to point you at it, is you can run Idem states from within Salt. I recommend playing with this. Try it out. Let me know what you can do with it. And that's it. I wanted to leave a lot more time for questions here because I figured there might be quite a few, and I want to get to all of them. Check out Idem on GitLab, gitlab.com/vmware/idem. It is separated from the salt stack space now. As of a few weeks ago, it's here in vmware/idem. Idem.readthedocs.io. This is a great place for documentation or how to get started. And we are currently building a new website. If you go to idemprojects.io right now, it's just under construction. There isn't anything there yet, but this is where we plan on having our one-stop shop for everything Idem. It's where you'll find artifacts for Idem binaries or tutorial videos, documentation. So keep tabs on that website and just be watching for when it's ready. And that's what I've got. So we'll open up for questions now.
Yeah, so we have a lot of great questions. If you go to the Q&A tab, we have about 13 minutes remaining in the session. And if you want, you can actually sort by popular, and you can see which ones have been upvoted by everyone else.
Oh, nice. Yeah, we'll sort by what's popular. So in long term, what things Idem will do better for users than Terraform, Pulumi, CDK, etc.? Where will it be worse than existing tools? So first, where Idem will be better is in its scalability and maintainability. If you want some functionality for a new cloud in Idem, you can write it yourself. You can write your own plugin. Like if you wanted Idem 10-cent cloud, you could probably write that in a day and you'd have it. You wouldn't have to wait for anyone else to review it or release it. As long as you're implementing the right contracts, you have it instantly. When I was starting at Salt and I was becoming the cloud guy, like we talked at the beginning, I was working on all of the Idem cloud tests, and for not just for Salt Cloud, but for all of these clouds, getting a new feature, like when AWS adds resource groups, it takes a long time for all of the tools to update to include that functionality. And in Idem, if you want that functionality right away, you could just write your own plugin if it was taking too long. That was called Idem AWS resource groups. Create your own project just for that, and you could have it up in a few hours. Have that, or hours is like I'm thinking of like writing tests and so on. You could have it up really quickly. So I think the Idem is scalable in its maintainability and in its ability to be written. It is very easy to write Idem states. So easy, in fact, that we have scripts doing it. You might have noticed when we looked at Idem GitLab, one of the folders here was an autogen folder where I'm using cookie cutter templates and various other files here. But every single file in Idem GitLab, you'll notice that they were written 1 month ago in the same commit. All of the states in Idem GitLab were written by automation. It turns out that I did it in a single day, the first iteration of it, because GitLab had a very clean REST API. I scraped the API, and it's like a post request always creates a resource. A put request always updates an existing resource. And because it was so clearly defined and so clean of an API, Idem GitLab was, I wrote it in a day with automation. So that's one of the advantages with Idem is it's so easy to write and maintain and test. And like with Idem AWS, where AWS is I feel like is one of the standards for cloud operations. You can contribute to Idem AWS and run the tests with local stack. You don't even need valid AWS credentials to run the tests or to develop on it. And so I feel like development with Idem is easier and it can progress at a much faster pace. Hopefully that answers. So does Idem SLS support non-YAML? Idem will read whatever. I've never used anything but YAML, Ginger YAML, but you can specify different input renderers using the rend project. So if we look at gitlab.com, substack, pop rend. Right now it can read JSON, TOML, and YAML. So there's your answer. It can do whatever the rend project can do. And you can write your own rend plugin if you wanted item to be able to read JSON it, or if you wanted it to read whatever your favorite file format is, you would just need to write a rend plugin, and then it gives that capability to item. So that's the answer to that question. From a strategic perspective, what VMware can achieve with item that it can't with other cloud provisioning tools? So there are, this is a bit, I don't know how much I'm allowed to say on this part. So let me see. What we gain with item, or what any team can gain from item, is, let's see. When I get asked the question, like, what can item do? How can item help this project? My answer always is like, item can do anything. Like, this is an idempotent runtime language. Just like, what can you describe in English? Well, I can describe anything. I can describe Star Wars or movies. I can talk about things that don't exist. Like, item is a language. You can use it for anything. The possibilities are endless. The main overarching goal, I guess, for a simple answer to that question, is we can, with item, with the scalability of item and how easy it is to add new cloud functionality and how easy it is to maintain item and test clouds with item, is what VMware gains is we can manage VMCs and we can manage VMware resources easily with item, and we can have multi-cloud operations. Like I can create an SDDC within VMC with my CSP credentials and have it wait for a VPC to exist within Azure or within AWS. The multi-cloud capabilities of item and the way that the requisite system and the credential system, I think, are really elegant compared to other solutions. And what you get with a describe command, which there have been so many different use cases that people have thought of for the describe command, like doing a rollback state or tracking what exists in your cloud over time. Like having a rollback state is huge with the describe subcommand. Or one of the things you can do with the describe command is you could download a description of everything in your cloud, and then with one set of credentials, and then upload it somewhere else with different credentials. So using the way item exists, you could do a migration. And I actually had a thing to show of that. So like if I run item describe I just borked my credentials. So if I point I've already pip installed item GitLab, and if I point item at everything in my GitLab project, we tried to test this before SaltConf, actually being able to do a migration from Salt project to the VMware open source space with item. And that had varying degrees of success. But I just want to show real quick, when I point item at a cloud, what is possible. So here, when I pointed at GitLab, it takes a second because GitLab has a rate limit on how fast you can hit its API, and that's what my throttle point is here. But it'll give me every issue that I have the ability to see in GitLab with my credentials. It'll show me every issue, every project, every group, everything inside of GitLab. I mean, I don't have access to user information, so I can see every merge request, and I have the ability to, yeah, I've just pointed at GitLab and let it run. And I got tons of information from the describe command. And now I can manage all of these things in GitLab easily from there. I'm going to go on to the next question. If you want to talk more about that, then hit me up in the Slack. Can you use auto state and then add more states? Or does it not make sense to do this? You can use auto state and you can write your own states. A use case I could imagine for that is like if you wanted auto states to just be like a direct wrapping of the API, like if you wanted like a state for everything, like I want a state for VPCs, for subnets, for instances, for users, for roles, and you want a state for every little thing, but then you wanted to write your own state for making sure that an instance exists and was salted properly. You could write your own state that uses other states. You could write a meta state. You could certainly write your own states. And auto states does not take away that capability. It just makes it a lot easier to get started when you're writing a new cloud resource. Okay. Will Idem support using AWS KMS or other KMS solutions for encrypting secrets? So we already have the account backends system for storing credentials or cloud profiles elsewhere. You currently can use LastPass, which is really obscure. It was a proof of concept. But you certainly could write any plugin for KMS or any other secret store for storing your credentials. We don't currently have the concept of a pillar inside of Idem yet, but that is certainly something that will come. And I see the future of Idem as it is not just like it can manage all of these cloud operations, but the big picture is similar to how we have salt formulas in Salt. I see the big picture of having Idem formulas. And you say, I want to set up an app. I want it to use Azure instances in the backend. I want it to also have some things in AWS, or like, and you give it your credentials, and it creates everything you need for your SaaS application, following a very specific formula. That's where I see Idem, the future of Idem going, is in rapid SaaS application deployment. Does Idem have an equivalent to dry run to Salt's test equals true? Yes, it does. I can say one of the flags is test. So I can say Idem state test.sls and give the test flag. And then what that does inside of the state for the code is the implicit CTX variable that gets passed to every state, ctx.test. This attribute gets set to true when you run Idem with the test flag. So why Idem when you can use Salt Cloud to deploy servers at AWS? So how do they relate? Good question. I feel like that's more of a big picture question I would want to ask Tom. Don't hold me to it, but I can give my best answer to that. Is I could see the future of Salt Cloud being Salt Cloud using. I personally could see a future where Salt Cloud is a wrapper around Idem, where Idem can manage everything, and Salt Cloud creates instances like it's a. I see Salt Cloud as being a meta state for Idem management. Or I could see a future also where Salt Cloud is able to, or where Idem creates instances and then Salt Cloud salts them. So I don't have an official big picture answer to that, but Salt Cloud isn't going away. I'm also very tentative. If you say, Tyler, is Idem going to replace Salt Cloud? That's a Tom question, or that's a big picture question that I would forward on elsewhere. The salt missing a describe, which points to the current state. So can you copy the output into an SLS? Yeah, easily. If I say item describe test, I could easily pipe that into an SLS file and then edit that file. So yeah, if that answers your question. Could item support deploying on-prem physical hosts like via PXE? Could item? Item is a language. And yes, you can describe anything with a language. I'd imagine you could. I would love to see that project come to fruition. Yes, you could certainly do it for deploying physical things. Item would need to have network access to your ILO or whatever bare metal you're using to set up those services. Item pop moved out of the Salt project, GitLab project now. Yes, because Item is part of VMware's multi-cloud strategy. As of a month or so ago, we now have a dedicated Item team. We have an awesome group of engineers working full-time on Item, and it's moved into its own space within VMware. I imagine that it is going to get even more resources as time goes on. And it is becoming, Idem is definitely a sibling of Salt. I would think of it as a sibling of Salt. And grew up in the same neighborhood as Salt. But it's going different places. It's moved out of the house with Salt. It's on its own space in VMware. It has its own space in GitLab separate from Salt. So what am I thinking of? Pros and cons of not having a state file in Item, like TF state, that describes what resources exist and converge the cloud in addition to state declaration SLS. So my default answer for a long time has been Item is stateless, and Item will have no internal state tracking. We're finding that there are some benefits we could have from some internal state tracking. Like for long-running resources, like if you're creating an SDDC or an instance, it can take, depending on what you're creating, it could take hours to fully provision. And so we are working on some internal tracking that will help. And there are some resources that can benefit from some internal state tracking, like creating a VPC in AWS isn't an idempotent action by default. And so we are working on some we do have a lot of features in the works of like connecting Item to the Salt event bus and having a message queue system inside of Item so that you can track the states from outside, and Itemd so you can have Item running as a service. And there are so many features, and let me see. And I think using Itemd, that's one of the things that we want to achieve is just run Item state until the cloud matches what you're expecting it to be. So I think that is possible. Can Item call Salt states? No, it cannot currently. Salt can call Item states. You certainly could write a plugin for Item that ran Salt states. I'd be interested to see that project too. Item/pop moved out of the Salt project now. Seems like a repeat question. Yeah, not all the renderers in Salt are in Item. but you could easily add more renderers to Idem because it's just the rend plugin. Do we have enterprise deployments usage of Idem that we should be knowing about? I don't know about that yet. Idem as a language is mature. The usage of Idem, like the specific implementations like Idem AWS, Idem GCP, and Idem Azure, they are at a stage where you can play with them and poke around with them. And I think we will start seeing, because we have a full team of engineers developing Idem, I think soon we will be seeing large enterprise deployments of projects using Idem. But I can't point to any today. What services in AWS can I use with Idem? Okay, so that's a great question. And I've left my window open here. So if we look at Idem AWS on GitLab and we look at the states, EC2 and IAM. Oh, that's it. So there's something interesting that's happening here. So you notice when I did Idem GitLab, I had all of my states were auto-generated, and I had automation write hundreds of states for GitLab resources. And I hand wrote these states, and currently, if I go to I don't have my we also are working on auto generation of all of the states in AWS. We're parsing currently we're doing it by parsing the Boto 3 API. We've looked at protobuf and Smithy models and other ways of getting all the functionality. So right now, all that exists is my handwritten states, but the Idem team is currently working on automation that will write code for every resource. Anything that Boto can create, delete, update, and list, those 5 functions, anything that Boto can do those 5 things to, Idem will have a state for. That's my answer to that. And when it happens, it'll kind of happen all at once. And the auto generation, it makes it so that writing code for Idem is even easier. There is some manual testing or some manual manipulation of the states that needs to be done after they've been auto-generated, but it gets us 99% of the way there. So soon we'll start seeing functionality for various clouds in Idem just start popping. And when we have it, we'll have it big and all at once. So that's my answer to that question. And it looks like is there an Idem cloud provider for ESX or VRA? There is one. If you look for, let's see, GitLab.com, VMware Idem. There is one for VMware internal stuff. There's CSP, VMC, and I believe there's one for NSX. It's not showing up in this list for some reason. But if there isn't one, it would be easy to write. But I'm not aware of one for ESX and so on currently. So I hope that satisfactory answered all the questions. If you want more details, or if you want to talk to me more about it, hit me up in Slack, or Dave, can I keep this room open to? Okay.
No, this will self-destruct in 5 minutes. But yeah, let them know where they can reach you and how to participate. And
so you can reach out to me on the Salt Stack community Slack. Send me an email. It's probably the least effective way to reach me, but it's worth a shot if nothing else works. TyJohnson@vmware.com. You can comment on any of these issues in GitLab VMware/Idem. I'm very active in that whole space. But Slack is probably the best and the quickest way to reach me. And do we have a breakout room, or do we have a room that I can join for talking.
Next, networking is up next, and I'm not entirely sure how that is formatted,
Okay.
but we'll see.
Well,
Yeah.
I'll join one of those rooms, and look for me in one of those rooms if you want to talk more about Idem.
Awesome. Yeah, thank you to
And
everyone
tomorrow
for.
I'll be giving a talk at later in the conference, in the second half of tomorrow, about POP. So,
Yeah, thanks for all the questions.
yes, thank you everyone for participating and for your excitement about the Idem project.
All right, take care. Thanks, Tyler.
Mm-hmm.